So today we're going to be solving this LeetCode problem, the 557th, and basically gives us a string with some words separated by blank spaces. And our task is to reverse these words while still preserving the blank spaces and the word's order, right? So we're going to implement the two-pointer algorithm for this. Usually, in a traditional way, you think about putting the left pointer at the beginning of the array and the right pointer at the end. But if we do this and try to reverse the string, we're not going to be preserving the word's order, right? So what do? We put both the right pointer and the left pointer at the beginning. We let the right pointer run through the array, and whenever it finds either a blank space or equals itself to array length, which means we would be one position ahead of the last letter of the array, we're going to call the reverse function. And in the reverse function, we're going to pass the array, the left position, and the right -1 position, because the left position will always be the first letter of the word, and right -1 will be always the last letter of the word. Okay. So what will happen in this case, let me fix this real quick. In this case, in the reverse function, we're going to have this situation here, and we're going to implement the actual two-pointer algorithm. Okay, we're going to reverse these guys. We're going to reduce one on the right pointer and add one to the left pointer. And there's going to be a while loop that will check if the left pointer is still less than the right pointer. Whenever this condition is no longer satisfied, we will leave the loop and return to the parent function. Okay, so I'm going to call the solution so far, as far as we've seen here, as I have explained it. And an important thing to tell here is that we're going to be solving this in Java, and strings in Java are immutable. So we're going to have to transform this string into an array of characters to solve this. Okay, so it looks something like this. Right? So I have set the exit condition to be right, less, or equal to the array length, because again we want to catch this last position here in order to pass the last letter of the last word to the reverse function, which will be right -1. And whenever it reaches one more than the array length, okay, we're going to be exiting the for loop, because it's going to mean that we have already reversed all the words in that array, and that's why this is the exit condition. Now what must we do? While the right pointer is running through the array, we want to check if it's a blank space or if it's the array length. So it looks something like this. And if one of these conditions is satisfied, we're going to call the reverse function. Right, -1. Let's write the let's write the reverse function here. We're gonna now implement a while loop in order to implement our two-pointer algorithm. Now we're gonna switch the letters. Add 1 to the left and reduce 1 to the right. Okay. And whenever we finish reversing a word, we're gonna have this exact situation here. And we want our left pointer to go to the first letter of the next word. So what do we do here? We code right plus 1. Okay, so left pointer will be equal right plus 1. And then we can continue to execute our for loop. The right pointer will run through the array again, and considering that we have this input, the next stop of the right pointer is the array length, which is 7 in that case. We pass that to the reverse function. It would reverse everything as we have seen. Then when it finishes reversing the last word, it's gonna execute again left equals right plus 1. That's not much relevant. What's actually relevant in this last iteration is that the right pointer will turn into 8, which in that case is greater than the array length. Okay, so being greater than the array length means that we're gonna leave the for loop, and it also means that we have done what we were asked to do, and we can return a string object. Okay, now the problem is solved, and let's execute. I hope I haven't forgotten anything. Running it again. We have an error here. Okay, it was just a syntax error. Okay, it was accepted. Now we can submit it. Yeah, it's a pretty good solution. Okay. And an important thing to say here is the big O complexity, right? So this line alone has O of n complexity because it runs through our array in order to transform it to an array of characters. This for loop also has a known of O of n complexity, time complexity. This other transformation, right, into a string object is also an O of n time complexity. And this guy here is kind of O of n divided by 2, but we ignore the constant values in the big O complexity, so it's actually equals O of n, right? But an important thing to say here is that this is not for each iteration. It's considering the whole execution of the array. This is not a representation of a nested loop, because it's not a nested loop in that case. Okay. So the general complexity of this algorithm is actually O of n, right? Because we are gonna sum these guys here, but and whenever we sum it, we will get something like, let me type it down here. We'll get something like O4 of n for n. As I've said, we ignore the constant values, so it's O of n. And that's it.